This is actually some pretty traditional algebra here. I mean, I know that it seems like there's a lot, but the W and T is just kind of a coincidence of the question. It's nothing new. We're just used to seeing this question with X's and Y's instead of these letters. But this is a point of intersection, right? We have two equations, two variables. We're being asked to solve for a weird thing, but it's just by finding the two variables we can get that weird thing. Now, some people can look at this question and instantly know what W and T are based on the equations. And if you can, that's awesome. Great. But that's just kind of good luck, right? That's just kind of, you're just seeing it in the moment. And I wouldn't want someone to stare at this question for like 5 minutes hoping that it clicks. If it doesn't click right away, you got to start working. Even if the work is going to be a lot of work and kind of a long process, just do something. So we know it's point of intersection. That means we need to eliminate one of the variables. So what I would start with is let's line these things up, right? We're usually not presented with these two equations in a sentence. We're usually presented with these two equations, one on top of the other. Now, again, there's a thing that you can do that you might just see, and it's going to be a huge shortcut. I'll come back to it. But for now, for most of us, if we don't click into that mode, we've got to do it the long way. So what would the long way be? Let's get rid of a variable. So what I would do is I would multiply the top equation by -2 so that I can eliminate my w's. So if I do that, I'm going to get a new equation. -4w minus 8t equals -28. And now I can take these two equations and add them up and eliminate the w's. So when I do that, I am left with, this goes away, -3t is equal to -3, which is going to make t equal to 1, right, if we divide by -3. So t is equal to 1, and now I can just pop that back into either equation. I'm going to go all the way back to the top one to figure out what w is. 2w plus 4 times 1 is equal to 14. Oop, I kept it a t. 1 is equal to 14. 2w plus 4 is 14. Subtract that 4. 2w is equal to 10. Divide by 2. W is 5. We're not done because I don't care about that. I care about what does 2w plus 3t equal. So 2w plus 3t. We know that w is 5. And we know that t is 1. So what do? That's 10 plus 3, which is 13, which is C, which is the answer. So yeah, it's a lot of work. But the thing about point of intersection is the work is very repetitive, right? So there's a lot of steps, but there's not a lot of surprises. And I think that that's important if you're trying to add on some points, is there are places where you just need to learn one new fact and you're good. There are other places where you need to learn how to use the SAT strategies to deal with a lot of weird situations and to help you through tough wording. There are other times, though, where you can just grind it out. And if you just do 100 point of intersection questions, you're going to be so good at point of intersection that this long process isn't really that bad for you. So this is a grind it out kind of situation. You got to get good at algebra, got to get good at distributing, and it's not a lot of different than that from question to question. So that's the traditional kind of longish way. If you look back now at the original equations, you can see why those numbers might appear to some people right away, right? 5 and 1, well, 2 times 5 plus 4 would be 14, and 4 times 5 plus 5 would be 25. So that jumps out pretty easily. Let me show you the other trick, though, that some people see. Let's kind of go over here. Let's try to rewrite these again. So we've got 2w plus 4t is equal to 14. And we've got 4w plus 5t is equal to 25. Well, what would happen if I just added them up? Without eliminating, just regular old adding. 2w plus 4w is 6w. 4t plus 5t is 9t. And 14 plus 25 is 39. Well, what does that get me? Seems random. Think back. What did we actually want to start? 2w plus 3t, right? 2w plus 3t equals what? Well, maybe you see it. If we divide everything by 3, what's 6w divided by 3? 2w. What's 9t divided by 3? 3t. What's 39 divided by 3? Well, it's the same answer we got. 13. This is the shortcut. Hopefully you see it. The SAT likes to put these kinds of shortcuts in point of intersection questions. Not all the time, but often enough that you might check for it. But I stand by my advice at the beginning. If it doesn't click quickly, if you don't see the shortcut right away, you can't just keep staring at it hoping the shortcut comes to you, because at a certain point, it's not a shortcut anymore. At a certain point, you've wasted more time looking for the shortcut than it would have taken you to just do it the long way. So you've got maybe like a 10-second quick look to see if that comes to you. And if it doesn't, you got to grind it out, you got to get to work, and you got to get the points the long way, because the points are what matter. It's just a good rule of thumb with the SAT. Start working. Anytime you start working, even if you're a little confused, it usually gets the ball rolling and lets you move on to the next step and the next step and the next step. And so the less time staring at a question, the better. Write stuff down, get to work, you'll add more points.